All right, on these, let's see if I can make them bigger, and then we'll make the top one 3, the second one, the next one 4 or 5. It's sure we're not gonna do the full-on deal. I'm gonna see if I can do one from each category. Which for some people, like that's it. Yeah, that's it. Others will be like, can you do more? Which is cool. Eventually, we'll do more. 4. Sorry, 3. 3, 4, 5. All right. So these are the equations. Eventually, I'll say, hey, use equation. Is this equation 1, 2, 3, 4, 5, and so on. So here it comes. See what we can do. Just like that. If I can find someone that takes your 15. All right, let's see if that's possible. All right, so let's back up. Geometric sequence. He's the famous one. Why do I? Something's not right. Okay. Dang it. All right, I'm going to start with 5 first, unfortunately. Because he's the one that shows up the most. He's the easiest guy. He has only 2 pieces of the puzzle. He has the letter A, and he has the letter R. And now I can't even see down here on these pieces of paper. And to find my old ones, I'm going to pause it. In this puzzle, A is going to be the initial amount. The initial amount. Now, there's a bunch of A's running around, but A sub 1, this guy didn't do A sub 1. Oh, no, it just tells you ratio. Look at that. They just write it on there. Sweet. Oh, they're not making this a mystery at all. So here's the deal. A sub 1 in a series of numbers, in a sequence of numbers, series, in a listing of numbers that may in fact be a sequence, the very first number is always called your initial amount, your A1, or in this particular case, I guess you just named it A. So see, first number of the sequence, initial amount, and then here, this beginning term. However you slice it, A, and alphabet is the very first thing. So do me a favor, even though we're trying to get to equation 5, and then something I haven't separated. In any case, please, you could draw an arrow, you could circle, circle, and put A sub 1. A sub 1 is normally the way they name it, even though these A's, for whatever reason, they're not putting the sub 1 here and the sub 1 there. A, the initial amount. As a matter of fact, circle this one, we'll do it twice. You should have it by that point. Then the last thing we're going to do is, depending on the problem that we're using, we'll need to know which thing we're using, which formula. So let's see. I didn't want to go in order, but I guess I am. Here it comes. Solve each geometric sequence and series. Find the 13th term in the sequence. Geometric sequence. All right. So series. Let me see how the other instructions go. Clearly, 3 is for this section. Not clear to you, but clear to me because they asked about the sequence. This thing has sequence. This guy says series. This guy says series. The question to you is, hey, when I'm trying to use one of these formulas, one of these tools, how do I know when to use number 3? How do I know when to use number 4? How do I know when to use number 5? We hope they put it in the question. Please find the geometric sequence. Okay, boom. You have sequence. I'm using you, number 3. Please find the geometric series. Oh, please find the infinite geometric series. So let's see when they change here. I know they put them in groups. I'm the teacher and I've taught this before. Sequence, still up to number 5. Anybody can see it when it switches instructions? Find the sum. That's a change. Sum. All right, you can put a line between 5 and 6. The word sum tells me that we need to add something together. The word series in the top guys also says, hey, that's addition. So let's go back up. Let's go ahead and put a plus sign after, that's for like the Fantastic Four. Turns out they've been trying to make this movie. They made it twice. Terrible both times. Terrible! I think I walked out. Yeah, I did. I think I got my money back on the second one. I didn't see the first one. The cartoon as a kid, I loved it. The guy stretches, the guy who's a rock dude. They tried so hard. +4. It's not a +4, it's a plus sign. And write the word sum. Why does he have them do that? These are some of your trigger words, so that when you hear some of these words in the question, you go, oh, okay, series, you always add numbers together. Sequences, you just list them. So here's a sequence, sequence. If I were to add all these numbers, I would turn this sequence into a series. This sequence into a series. Let's see if I can find the word infinite, and then I'll separate.
On geometric series, is that a plus or four?
It's a plus.
Okay.
It's just because I'm running on
Yeah, I get you.
Yeah, this program doesn't make it smooth. Keep looking for a thing. Find the sum. Okay, I see you sum. Find the sum. I see you sum. Find the, oh, there it is. Take a look at number 9. Read all of number 9. I wish you had a highlighter. You can mark a key word in there. Infinite series. Put a line between here. 4. Fantastic 4. 9. The unfantastic 4. And that's so sad. I'm being all mean to it. Like this one student who's mean, basically saying she hates me as a teacher. Well, she didn't hate me as a teacher, but she'd prefer to be elsewhere. She let it be known. You ever tell a teacher? You say to your friends, yeah, that's that fool, I hate him. You say to them, yeah, he's that fool. But not in the presence, because then the teacher could be offended, like let's say me. Then I took my amygdala, almost made me want to say, hey, I don't like you either. But my amygdala didn't. I fought through it. I go, you know what, this young person, they're entitled to their opinion. Mr. Wilson was my favorite teacher, which means Miss Davis wasn't. So it's okay. I need to be someone's not favorite, but just don't want to hear it. You know what I mean? It stings a little bit. Then you go home, trying to get out the head. You think bad thoughts about them. You hope a car drives by. All right, later. 3 plus. Yeah, that's cool. Well, it's where your food does a final tour. Like your small intestines are right here. So when you touch here, you're like, oh, my stomach's so full. No, you're not touching your stomach. You're touching your small intestines. Here, oh, my stomach is so full. Now you're touching your stomach. It's protected partly by your rib cage. Then it goes here. Here's small intestines, food. No, it has to go down. Because your ascending colon is over here. Transverse colon is right here. Descending colon is right here. Goes to the rectum. Boom! Your food is free. Yeah, it's free after that. To be a PE coach, you have to learn that. A-R-N, let's see. You're not going to let me write? You're not going to let me write? You're not going to let me, thank you. Hey, the A is always easy. In problem number 1, and I don't have that much space, you have to use your space wisely. My A is what's the A in number 1? 2. Yeah, 2 is the first number. R is pretty easy too. To get the common ratio, all you do, to get a common ratio, you just take the second number and put it above the first number. You take the third number and put it above the second number. You take whatever the next number is in line and put it above the preceding. To come before, like a prequel, the story that came ahead of. So you put above the preceding. What is he talking about? I'm going to put a 4. Now there's too much information. Above the 2, I'm going to put an 8 above the 4. This is getting my R. A ratio is a fraction. A fraction is a division problem. Put the number above on your calculator, hit top number divided by bottom number. It gives you an answer. If the top number is bigger, you get a whole number, like a 2, a 4, or 6. If the top number is smaller, you get a decimal, like 0.2, 0.4, 0.6. In this case, anybody know what 4 divided by 2, or rather 4 divided by 2 is, or 8 divided by 4? 2. Thank you. Turns out that the common ratio, you must get the same answer when you divide the first fraction as when you divide the second fraction. In other words, if the ratios come out different, something's wrong.
Well, that don't matter.
No, because if 2 win, they'll all be exactly the same thing. In other words,
well, what if one goes over? Oh, never mind.
Yeah, it'll mess up the thing.
Okay.
And for the purpose of them teaching you, they're not going to mess it up.
All right, cool.
Yeah. So 16 over 8 is still the same, 2, whatever. In any case, we got 2 out of 3 pieces. I forget what this last one is, so let me see if I can find out. The number in the sequence. Oh, they don't want to find out the first number, the second number in the sequence, the third number. They give those to you. Here's the first number in the sequence, the third, the second, the third, the fourth. You could continue, what are they doing, multiplying by 2?
Yeah.
Yeah. You could keep multiplying by 2 until you get to the 13th one. But some math person goes like, what? I need to know the number 200 for this experiment I'm doing. Like, what will that number be? You know, you just keep multiplying. Like, no, there must be a way to be able to, just some formula that will tell us, and that's what they figured out. So we want the 13th one, you become our n. Once you have all the pieces of the puzzle, it is true, you punch them into the calculator, it spits out a number. But make sure you put in parentheses. We're going to use like a bunch of parentheses, some that are needed, others that are gratuitous, like gratuitous violence in some movies, gratuitous, whatever. Here you go, Thomas. The other thing I want you to do, the first 3 times you do any of these problems, at the very bottom you only have 2 of them, so you get JIP. Sorry, not JIP, but you get whatever. Please write out the formula every single time. Hey, why are you going to do that? You need to memorize it, and by writing it every single time, you'll do that. All right. I won't give him a hard time because I know she's going to pass right away. All right, here it comes. A sub 13. What does that mean? Oh, no. Just write the n first. A sub n equals the a sub 1 r raised to n minus 1. Pieces of the puzzle. If I go slower, the equal sign will do what it should do. Check the clock. First term is a 2. The r we determined also 2, unfortunately. Raised to the n, which was a 13, minus 1. Here's what I want you to do in your calculator after you write that down. And again, every time you do one of these, I do want you to write down the formula. You'll thank me later on, because by writing it down a million times, it'll be inside your head. Punch into your calculators that now record. I don't know what to say so far. So we're using the 5th formula. All right.
0.2, bro.
0.2, not 0.5. Be careful what you write, and I will look at what you write. So if you put something off, but you do the right thing with it, I can give you some points for it. And voila, you put it into the formula. The only thing they can do, which they will do on the test, is give you weird numbers so that I can see them. But you got a calculator. I'm sure I'm not teaching this right. This is way too easy. There must be something I'm doing wrong, which is why we'll show up in Unit 9. But here's the formula. Please write out the formula. A over 1 minus r. This is for infinite series. In other words, what if you started adding numbers or multiplying numbers? This is we're multiplying by 1/3. No, by 1. We're multiplying by something, but it's getting smaller and smaller and smaller and smaller. This leads me 1 minus r. This leads me to a famous thing in philosophy. If you ever get to a philosophy class, which I hope you do in college, oh, they're the best. Philosophy asks the question, how do you even know we're right here right now? Well, we're here, aren't we? Then someone responds.
156.25.
I don't know. With a fraction, sometimes you have to put a parenthesis around the bottom. Someone do it the bottom without a parenthesis. Someone do it with a parenthesis, and let's see if it gives us a different answer. Say your answer again. I'll put it down, and we'll take it back if we need to. 156.25.
Yeah.
All right. Let's find out if people got anything different. A is the 5, is the initial amount, the alpha, the beginning, so 5. Anybody know what R is? Someone different? Yeah, 3, this one's kind of easy. I wish I could draw arrows to say put it above the number. You do it twice technically. Now, because these are baby problems for you, you can do 15 over 5 and it's a 3 and boom, you win. But technically, you're supposed to check that 45 over the 15 to see if you also win. I mean, there's some scenario where it's not even a sequence. 3. And what's n? 14. This is the one, let's see. Find the sum if the sequence. Do me a favor, write down the word series under the word sum. Dang, that's no good. When you are asked to find the sum of a group of numbers or of a sequence, the math would say that, hey, what's the series of the numbers? What's the series? What's the sum of the series? Maybe not. Maybe series 2 refers to the fact that you're adding the numbers. And so you need to say, what's the sum of them? Okay. Say the sum of the series. 14, there's your puzzle. Write out the formula, please. I only give you a few of these. I don't even know this one because it's been long. I feel like it's an A, parentheses 1 minus something at the top.
1 minus r.
Rn?
Yeah.
And then on the bottom, 1 minus r?
Yeah.
we're going to put it in, then I'm going to comment on the amount of parentheses you need to put in, and then I'm going to see if I'm going to review the other thing, give time for some people to look at the thing the last time, some people to mess around with it, maybe a key assignment. Even I'd love to do one problem on the other page, so that way, I'd love to do that. All right, here it comes. A is a 5. If you need extra paper, there's some scratch paper behind this thing. 5, 1 minus a 3 to the 14. All over a 1 minus who? 3. Now here's the challenge on this one. I'm going to say it so that people at home can hear it. It goes like this. It's 5 open parentheses, right? And because the top has more than one piece, that's going to be another open parenthesis, 1 minus 3 raised to the 14th power, close parenthesis, all divided by open parenthesis, bottom, 1 minus 3, close parenthesis for the whole thing. There are a lot of parentheses, but anytime there's 2 pieces, you need parentheses for that, 2 parentheses for that, plus the closing of the whole thing. Try and punch it in, let's see. On this one, you put it above and subtract. Say it again. It's a 55. Mine won't let me write 55 minus the 50. I need to put this on here because students need to see it. 55 minus. And then you could do 60 minus. So you put it above and subtract.
So what do we do what do we do when like it's going down?
So you're gonna put it above and subtract. I'm gonna see if you have it.
Okay, for like number 5, like what do we do there?
Are you gonna put it above and subtract, and it'll just be a negative number. I'm gonna see if that works or if it messes things up. All right. So in this one, what do you do to get to the next number? You add 5, add 5, add 5. I think if you subtract 5, subtract 5, you just put a negative number there. What is the n? Oh, sweet. All right, there it is. And then when you write out the formula every single time on this one, this what is this? A sub n equals something.
Wait, tell me, where did the 5 come from? B. Oh, is that the one where you subtract?
Oh,
ADN.
ADN. A. And you also notice this is also the formula to graph a line. Y equals mx plus b. Y equals mx plus b. They just put out order. Put them in. A, what are you, A, 50? That doesn't even look good. I'm watching that. I'll do this and do one more, and then we're done with these. By kind of hands on 7, 5 minutes to review. Somebody didn't need that much time, but tick, 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 tick. Where are you? You're 50. Come on, you can do it. 50, slow.
5.
The 5er.
And then 26.
26.
Yeah.
By writing out the formula of that, if you mess up after that, I'm giving you some points for some. Anybody know what the final answer is? 25.
55 times 55.
Right. Yeah, but I'm saying like the whole thing.
Yeah.
You're 25, $1.25.
13.75.
15.
13.75.
13. That feels weird. But if it is, it is.
175.
175?
Oh yeah, I got that.
It feels small.
What goes on the other side of the equal sign?
The same thing I love with the A sub n.
Oh, A1.
Now I'm going to write it with another number. You know how we have f of x? And they'll say, what's f of 2? And then you work it out. Well, this A sub n, the 26 we would put there, but it's not part of the problem. It's just the math way of asking. You said 175?
Yeah.
It's the math way of saying, what is the 26th term?
A26.
So this isn't part of the problem. This isn't let me divide. The left side is a function. It just tells you, hey, the name of this thing, the name of this formula is A sub n. And even that's not even correct, but just know you don't do anything on the left. All right, let me do one on these last ones. Find the series, the sum, if the sequence contains 20 terms. The other guy is n over 2. the first guy plus the last guy. I don't know who figured this out, but I know they were jumping up and down. The reason they were jumping up and down, they found this one out is basically they had like 100 numbers. This eighth grader, no, he was 8 years old, or he was in 8th grade. This guy named Gauss, when he's like sure, I'll keep it on there. He's like in elementary school back in the day somewhere, maybe in Germany or something. His teacher, as the story goes, was giving him some busy work to keep the kids busy. I want you guys to add up the numbers from 1 to 100. 1 plus 2 plus 3 plus 4 plus 5. Gauss, who became a famous mathematician, he, in, I don't know, 5 minutes or whatever, other kids like add and add and add, and he's all playing with his toy or something. Hey, are those some chucks? You know what Chuck Taylor is?
No.
See how honesty works? No big deal. And so you add and add and add and add, and then finally, the other kids, teacher's like, Richard, Gauss, say call my last name. What are you doing? You're not. I'm finished. You're finished. You got the answer to that question. Why don't you show us, young man? And he comes up and he puts like 101, which I think is the answer to it. Can't be 101 because right. It's some answer that boom he gets right away. And it turns out either in his head he figured it out and saw the formula, or he was a genius. But I think we attribute this formula to him. Adding up any group of numbers, you just need to know how many numbers are in the sequence. That's the n. There are how many in this one? There are 20 terms. They tell me if you had 20 numbers and they're following this order, when you add them all together, what do they add up to? Well, there are 20 of them. Good. I got that. Hey, what's the first number? Oh, shoot. Dang it. I remember this now. I have to give you the last one. There's a special way to find it that makes it extra hard, which is all that they can do to make this problem harder, because if we just give you the 3 pieces, you divide the n by 2, add these 2 guys together, and multiply. And I'm like, well, why are we teaching them that? So they made it harder. Oh, shoot. It's not on this paper. Make up a number. Make up a number. And then when we find out the real number, we'll fix. I think it's 998. I'm going to put 998 there. Rings a bell. I'll be so proud of myself if it is 998. And for this one here, I'm going to have to give you a number 2. Let's put 1,000 in quotes for now. It can't be true. I'm just making it up. Why do you just make it up in front of my desk? Because it kind of doesn't matter. Once we know what it is, how do we discover it? Either you figure it out yourself, or I just give it to you. It's the formula that matters. Let's plug in with 998, which in my brain it says that's it. From there, I'll ask 2 questions about that other test, and then in a weird way, we'll kind of all be making our own decisions. So somebody get out here about 5 minutes early. It's my best record yet. I'm going to put on this top guy 998. No, 20 is at the top. Inside the parentheses, a sub 1 is a 1. That part's true. And then what are we adding it to? This made up number is 998. And then I'll do it for real with the 1 to 100, because you know there are 100 numbers in that sequence. And that one we can see what it actually turned out to. 10 times something, what do you do? 999. 10 times 999 should be like 9980. That 90? Oh yeah. All right. So that's a fake one, yes.
You keep adding over every 20 times, might be 190. Is it 190?
What I put?
You put 990.
I trust in 999. You can do it. You did? You did that? Pause. Please find the sum of the series 1 plus 1, 2, 3, 4, 5. 1, 2, 3, 4. And we get it. all the way to 100. Can I dot? Okay, from 1 to 100. Now I know from 1 to 100 there are 100 numbers. So in this problem here, my n, how many numbers are there? How many terms? There are 100, got that part. My a sub 1, I know that's going to be a 1. And my a sub n, the last number, is also going to be 100. Let's see what this one does, and then it might make some sense what you're saying. N is a 100. I'm using the space that I have. Clearly, you guys would use the space you have, or you can just watch. All right, so let's see. I got 100 over 2, which is a 50. I have a 1 plus a, oh, maybe you're right, 100. We know that's going to, someone do 50 times 101. That's going to be 50, 50, I think. Someone do 50 times 101. All right, let's